Okay, this video tutorial looks at the mathematical strand of real number, and more specifically, we're going to focus on our understanding of ratio. So, first of all, you need to understand what a ratio is. Now, a ratio is essentially an ordered comparison of quantities of the same kind. Now, what does that actually mean? Essentially, it means that you are comparing things that are the same or have the same units. So when we talk about the same, we're actually talking about the same units. Alright, and that's very important because ratios are always comparing the same units. So it's really important that you understand how to write ratios. And as you can see here, ratios are always written something to something. An example is 2 to 1. So this is written as 2 to 1 or 2, 1, where this section in the middle represents our 2. And you can see another example we've got. So if you wanted to make pancakes and the ratio for the recipe is 1 cup of milk to every 2 cups of flour, well, this would be a ratio of 1 to 2, or you would write it as 1 dot dot 2. It's important that you make sure the units are in the same, are the same for each of your quantities. Here you can see we've got 1 cup and here we've got 2 cups. Because they are the same, we can then compare them. If they're not the same units, then you can't write them in a ratio and you can't compare them. So in a similar manner to fractions, ratios can be either broken down or increased to make what we call equivalent ratios. So as an example, let's say if we had 20 women for every 4 men, you would write the ratio of 20 to 4, or you'd write it mathematically like this. But we know we can actually cancel that down because we can actually divide by 4 on both sides, and when we do that, we end up with a ratio of 5 to 1. So you can see this is a simplified version. You see, simplified ratio, just as we would simplify fractions. So we can always also use ratios to solve problems. So here's an example of a problem that you might encounter. If we wanted to know how many people were sick in Adelaide, knowing that the ratio of sick people to healthy people is 3 sick to every 700 healthy, and that there are 700,000 healthy people in Adelaide, we can use this ratio to work out how many sick people there are. So the first thing we do is we write down our ratio of 3 to 700. And we know that these are our sick people, and we know that these are our healthy people. We know then that there are actually 700,000 healthy people. But we don't know, and I'm going to put it as an X, we don't know how many sick people there are. But what we can do is we can work out our multiplier in this particular case. And we work that out by having 700,000, and we divide that by our ratio of healthy people, and that gives us a total of 1,000. So that's actually found out that our multiplier is 1,000. So we've actually times by 1,000 in our ratio. This is just an equivalent ratio. And whatever we do to one side, we have to do to the other. And we know that 3 times 1,000 is 3,000. So our X value is 3,000, which means there are actually 3,000 sick people in Adelaide. So not only can we use ratios to solve problems, but we can also use ratios to divide quantities. So let's say we had $100 that we were going to divide between a class of 12 boys and 8 girls. This is how we would use ratios to divide the money. We essentially have a ratio of 12 to 8. Okay, that gives us a total of 20. Right, because we have 12 boys, 8 girls, 20 people. Now, if we get our quantity, which in this case is $100, and we divide it by our total of people, or total of the parts, let's say, then we can work out that one person, or we'll call it part because questions aren't always about people, right? And that means that our total of one person or one part must actually also equal $5. Now, if we have a ratio of 12 boys to 8 girls, and each one of these is worth 5, so we times by 5 and times by 5, that means that we must have a ratio of 60 to 40, which means that $60 would go to the boys and $40 would go to the girls. And a way that we can work this out is we can double check that if we add the boys and the girls, so if we add our 60 and our 40, then we hopefully get our total that we started with, which is 100. It says how much money would each boy or girl get? Well, each boy or girl would get $5. So you're now going to come up with some practice questions. Please feel free to pause the video. When you think you've answered all the questions correctly, continue the video and we'll check and see how you went. Okay, so here are the practice questions. Like I said, please feel free to pause the video. Once you think you've got the answers, continue the video and we'll see how you went. Okay, so in our first question it says, if the Adelaide Zoo has 40 otters and 25 snakes, what is the ratio of otters to snakes in simplest form? Well, the ratio is simply 40 to 25, but this is not in simplest form because we can actually divide by 5 on both sides, and that's going to give us a ratio of 8 to 5. So 8 otters to 5 snakes. The second question said, if a fundraising organisation makes $90,000 at an event and wants to donate some and keep some of the fund for future events in the ratio of 2 to 1, how much money would the organisation donate? Well, we've got a ratio of 2 to 1, which actually gives us a total of 3 parts, and our total money is 90,000. I'm going to divide that by 3 to work out what 1 part is, and in this particular case, 1 part is $30,000. Now, if it's in the ratio of 2 to 1, so donate to and keep 1, and 1 part is 30,000, in our ratio of 2 to 1, we actually multiply both sides by 30,000. Then we end up with $60,000 to donate and $30,000 to keep. So therefore, the organisation would donate $60,000.